Our next situation is taxes, and we're going to do this on page 17 in our books. When we talk about percents with taxes, we're not talking about the things that come around in April that make your parents feel really, really stressed and cranky. What we are talking about is the thing that we are required to pay every time we buy something. It goes to fund all the stuff like teachers, as awesome as me, roads, schools, and all that good stuff that help to keep our day-to-day lives functioning. We have to pay sales tax on every item. Typical sales tax in the States is between 6 and 7% depending on what it is. When you go to other countries, it varies. Prime example, Canada, sales tax is approximately 12 to 14%. So we're talking at least doubled. So things in Canada are very, very expensive. Like your dollar menu is actually your $1.10 menu because you pay $1.10 for it, not $1. Anyways, let's take a look at the first example. Casu is buying a chair for $110. If he has 6% sales tax, what will his final bill be? We know the bar at this point is going to represent 100%. And 100% is going to be that $110. But he has to add on a 6% sales tax, meaning he is actually paying 106%. This should look very familiar. The nice part about tax is it's pretty much the same as markup. It's being added onto something for a purpose in order to make money, gain money, that kind of thing. So we're talking about 106%, of that 100%, and $110 is the cost of the chair that he got before tax, and we want to know what's his final bill going to be. We cross multiply as we normally would. And we get that the cost of the chair plus tax is going to be $116.60. If we did the equation, because you still have that option, we move the decimal 2 spots to get that the tax percent, or the percent, is going to be 1.06 of the $110 that he spent, and that'll give you your final bill. So we multiply 110 times 1.06. The second one on page 17. Millie finds a shirt she wants to buy for June. For her birthday. She only has $27 to spend. The shirt costs $25. She has to pay 6.5% tax. Does she have enough? The bar we know represents 100% of the cost. And the cost of the shirt is $25. You have to add on tax, which is 6.5%. This means that she is paying $106.5% of the cost. When we set up our proportion, $25 is the cost of the shirt. Therefore, it's going to go in the denominator where 100% is the cost. But she has to pay tax. So she has to pay 106.5%. It's a percent, it goes above 100, and she has to pay it. There's no getting out of it. And we're wanting to know if she has enough. We cross multiply. A mistake that students make at this point is they try to put the 27 in on the proportion, and we're not ready for it yet, because the 27 is only going to come into play when we're asked, does she have enough money for the shirt? Otherwise, we don't need to worry about the 27 yet. We're going to have to round, so we say, what does the 5 make the 2 do? And we get that the cost of the shirt is $26.80. $4.63. So yes, she has enough. Because she has $27, so she ends up getting 37 cents back in her change. If we are doing the equation with this, we take our decimal point where it's at and we move it 2 spots. Therefore, we have 1.065 is our percentage of the $25 shirt is going to give us the cost. We multiply $25 for the shirt times 1.065, and that's going to give us $26.625, which we ran $26.63. For students using the equation, the biggest mistake occurs on problems where the percent is already in a decimal form and they either don't think to move it or they move it incorrectly. They start after the 5 or those kinds of things. So just be aware of that the proportion makes it a little easier because you don't have to worry about moving a decimal. But there can be a little bit more work when doing the proportion as opposed to the equation. It's completely your choice, though. You go with the way you like the best and makes the most sense for you. Okay, the next one. You buy a backpack for $34.82. The tax is 9.25%. What is the amount of tax? So we know the bar is going to represent 100%. Which is the $34.82. And they are adding on 9.25% for tax. Apparently it's an expensive backpack, it's a decent backpack in another country. And this is what we're looking for right here. Your tax is right here. It's the amount they're adding on to it. When we go to set up our proportion, we are simply wanting to know what is 9.25% of the $34.82. We're not asking what the final bill is. We're wanting to know what the amount of tax is. So in this case, we did not have to combine our percents in the beginning because we are simply just being asked about, well, what is the tax? We cross multiply like normal. And of course, we're going to have to round on this because we get that the amount of tax is 3.22085. We don't really care about the 8 and the 5, and we say the 0 makes the 2 stay the same. So the amount of tax is $3.22. We also could have gotten that in our equation. But again, this is an example of one that students often mess up on because of the decimal and the percent. You move it 1, 2 spots. So your percent is, as a decimal, is 0.0925 of the 34.82, meaning we just have to multiply 34.82 times 0.0925. The second problem, you buy a watch that costs $45. The tax on the watch is 7.5%. What's the final cost? All right, we have our bar, which represents 100%. And 100% is the cost of $45.50. They've added on a tax, which is 7.5%. To get the final cost, we need to know that we are paying 107.5%. We set up our proportion. We cross multiply as we normally have been. And we know we're going to have to round because we get that the final cost is $48.9125, which doesn't make any sense. Take the 5 off and say, what does the 2 do to the 9? Makes it stay the same. So the final cost is $48.91. If we're doing the equation, which you don't have to do, I'm just giving you the option, 1.075 or 107.5% is the same thing as 1.075 when we move the decimal 2 spaces to the left, and we end up multiplying that 1.075 times the 45.50 and rounding to get $48.91. Now for the last one, the final cost including tax of buying a pair of jeans, so as I said including tax, is $37.82. Tax was 6.5%. What was the pre-tax cost? So we have our 100% here. And this is what we're looking for. This is going to be your pre-tax cost. They added on 6.5%. The $37.82 represents the entire percentage of 106.5% because it represents the pre-tax cost and the tax. So when we set up our proportion, we have 106.5% out of 100 because the 106.5 represents the pre-tax cost, the wholesale price, plus the tax over the whole amount of 100%, which is what it cost them at the store, and that's actually what we're looking for. And the total amount that we spent was $37.82. We cross multiply like normal. And we end up having to round because we get a funky decimal, 35.511, blah, blah, blah. And we say, what does 1 make the 1 do? It makes it stay the same. So we find out that the pre-tax cost was $35.51, which we could have found out by also using the equation. 1.065, we move the decimal 2 spots to the left and we get 106.5% turns into 1.065. And the 37.82 is going to be our part because that's what the cost was with the tax included. And we're looking for the pre-tax cost or the wholesale price. So what we have to do is say $37.82 divided by, or 37.82 divided by the 1.065, and then we round and we still get $35.51 or 35.51.